Alright, let's build a Pokédex for the Apple Watch. So, we get a URL from Poke API. This is a REST API that is completely free to use. And I want to build a list of Pokemon from the first generation. So, this is the link that I want. This is the base URL plus the query. And when we click submit here, we get the response down here showing that everything is fine. We could just click this URL and the browser will paste the JSON response here. But I have an app called Paw. If you've ever used Postman or something, this is exactly that same thing, but in my opinion better. And all we need to do is paste the URL here. It will fill these parameter fields automatically. And once we run this, we'll have a JSON representation on the right. You can view it as text, you can view it as normal JSON, whatever. Another option is to copy this text, and I like to use sometimes this page called JSON Formatter, and this will do the same exact thing for you, so you will get nicely organized JSON from which you can then model your Swift code very easily. So now that we have that, I'm gonna use this just for the sake of it. Let's open Xcode and build a new project. So, like I said, we could do any of these platforms. It doesn't really matter. That's not the main thing here. But let's just do a watchOS app, because that is so simple and easy to do in Swift UI. So, let's call it Pokédex Watch and watch only app. First, what I usually like to do, I usually delete these. They are not needed. If we need them later, we can add them later. It's all good. So let's have a look at this JSON then. What we need is the results field with the array of Pokemon. So this results field includes an array of objects, and each object has two fields, a name and a URL. So this is as simple as JSON gets. All we need to do is map this object into Swift right here. These two lines, or yeah. And then we make an array of that. And then we make a network request and we populate that object and that list and display it in the app. We could do way more, but to keep the video shorter, that's all we're gonna do for now. Okay, so let's start by adding our model. So this is gonna be called Pokemon Response. And I like to call these models that are the very highest level of abstraction with this response suffix to keep things, I guess, easily readable. And whenever you decode JSON, everything needs to be codable. The codable protocol is essentially there to help you decode and encode JSON data. And since we are building a Swift UI app, we want the struct to also be identifiable, which means that we will need to provide it a string field. So essentially the identifiable protocol, it requires us to use an ID so that Swift UI then can parse it correctly. So in our Pokemon response, this is our response right here. We had these 4 fields and we are only using one of them, the results one. So what we do here is we type out the name exactly correct. It has to be the same type. And I'll just put the string here as a placeholder. And then for the Pokemon object, we're gonna do this, add it, conform it to codable as well. And then it had the name, which is of type string, and the URL, which is of type URL. And then the results included an array of Pokemon, right? All right. So that's essentially all of our JSON mapping done. That's it. That's as easy as it gets. Next, we want to make a network request. So we make a Poke API service object. I'll make this a class. It could be a struct too, but it doesn't really matter. So we're gonna write an async await method called Pokemon, and it will return a Pokemon response. And since it is an async await, we need to do it as an async function. It will also be capable of throwing. I will explain this later. Our URL is the same one we used earlier in the browser. And we can force unwrap this, since we know that this URL exists. You could safely do this, but doesn't really matter right now. And then we'll make our tuple of data and response. And we will try await this with URL sessions shared data task. And we're going to use the from URL field or parameter to double check that everything is working. At this point, we will print out the data in UTF-8 format, which is the same thing that the browser will show you when you click the link in Poke API. The same thing as here. Next, we're gonna check that the response is valid. So HTTP response. We're gonna downcast the response as a HTTP URL response type. If something is wrong, we're just gonna throw out the error. And since it can't find a simple error here, we'll create an enum called HTTP error, which conforms to error, and add one case here called bad response, and then throw that error out of here. Now that we have the HTTP response object, it has a field called status code. We can switch over that. So HTTP response.status code. If we get back something between 200 and 299, we have success. That means that we want to decode the data that we got. If it's something else, we have an issue. That means that either we gave it a bad URL, the backend is down temporarily, or something else is wrong. We could add those cases here as well, but we're not going to do that now, since this is pretty basic stuff about HTTP. You can Google that very easily, what all those different numbers means. 500 or something is bad server problems. 400 is that it's most likely our fault. And then anything with 200 is that everything is fine and working and things are good. Roughly speaking, of course. And let's just throw the same bad response from here also. To keep things simple. But in the case we get a success, then we want to decode the data here. And the data here is going to have our Pokemon response in it, but we need to decode it first. So let's put a decoded response here, and then use the JSON decoder and its decode method. And we want the type Pokemon response.self from the data that we are getting here. And this can throw. So it has to be inside a do catch block, and it needs to be marked with try. If there are any issues, we will just throw that error out. And then we will return the said decoded response, which is of type Pokemon response. What we actually want here is to return the Pokemon that we got back. So we want to return an array of Pokemon. Because if you recall, our responses here have the results type, which is of array Pokemon. Since our async await method is returning an array of Pokemon, when we return the decode response, all we need to do is add the results field to it. And now we are returning an array of Pokemon, and everything is all good. I just needed to delete those references to the preview assets that we deleted earlier. And now we can test this by going to the root of the app, and we're gonna call the onAppear method. And since this is an async await method, we need to wrap it inside a task. Here we're going to do a do catch block because our method can throw. And essentially what this throwing means is that instead of printing out errors and just doing everything very manually, whenever we encounter an error in our method, we're just going to throw the method out from the method and then catch it at the call site. It's a pretty convoluted concept if you've never used it before, but once you get it, you will understand why it's way better than anything else. And I might make a separate video about that in the future. Just let me know if you want to see that. So essentially here we're going to do try await Poke API dot Pokemon. This method returns us an array of Pokemon. So what we can do is that we can just print this out directly and see what happens. And if there's a problem, we will print the error here. I guess we can do it now. We'll just do a normal error. All right. So now if we run the app, it will open the Apple Watch simulator and immediately fire this method. And we should see something in the debugger already. So, as you can see here, we both see the print statement that we have here. So that's the first one here, this optional part. But then the next one is an array. And this is our response, a decoded JSON response. So now we can remove this print statement. And if we run it again, we will only see the array of Pokemon, like that. Our network layer is working. Next, we'll create a view model. I guess Pokédex is the correct name for this. And this is going to import combine as well. And this is going to be an observable object, which is a protocol that allows SwiftUI to easily update itself when something in the view model changes. This is, in my opinion, one of the better ways to structure a SwiftUI app, or any app for that matter. Here, we're going to use a published property called Pokemon. Surprise, surprise. And guess what type this is going to be? Well, this is going to be an array of Pokemon. And we're going to initialize it with an empty array first. So what this view model will have, it's going to be a very simple thing. All it's going to use is our Poke API service. And we're just going to call it service. The first thing that it does, when it initializes, we're going to have a private method called Pokemon. And it's an async function, and it returns an array of Pokemon like we had before. And here we're going to do the error handling inside our view model, not in the view. So we do the do catch block over here. And here we can just give the Pokemon there's a lot of Pokemon, right? But I hope you can still reason about this. It is what it is. This is what happens when you build a Pokédex. You have Pokemon all over the place. So we're gonna do the empty Pokemon array, and we're gonna add whatever the return gives us back. So the service.Pokemon method is going to return an array of Pokemon, and we're going to set the published property with that data that comes back from there. And if there's an error, we could show an alert in the app, but for now let's just print it out like that. I guess we can do this also here at the same time. So error message is an empty string, but if something goes wrong, then we will set the error message to be the error.localized description. So if this ever changes, we're going to react to that in the SwiftUI layer. And this is actually not going to return anything. That was a mistake by me. My bad. All right. So once this view model inits, we are going to wrap this Pokemon call in a task. And whenever we initialize the view model, this is going to run, and it's going to populate the Pokemon array and display it in our view, which is here. So for SwiftUI, when you declare these observable objects, you want to use either a state object or observed object. But since this is our only one and we only need it when the app launches, we're going to use a state object. And we can do it already here at the very beginning of the app. And our content view will want a model observed object. We're not going to initialize it here like that. And then that means that our preview will want something. We can just give it a normal one. Here, we're going to give it the model that we defined above. So now we are routing the view model from the very beginning of the app's lifecycle all the way down to the view. And if we had several views, we would start them all here at the very root of the app and then port them over to whichever view requires whatever view model. That way we are in full control of our data. We see where everything is going, and everything is very clear. There are other ways to do this, but this is how I prefer to do it. And here, now that we will get back our array of Pokemon, we can just wrap it in a list. And our view model had the Pokemon array, so we will use that array as the list's data. And we'll name the parameter Pokemon. And we will then just make a list of text components with the Pokemon and its name, like that. One more thing, SwiftUI requires that if you use these types, they should inherit identifiable, which we already did for one of the models here, but we didn't do it for the Pokemon model. So all we need to do is add identifiable and then also the ID for this, like that. So now that is working, and now it won't complain anymore in the view layer. And now let's see what happens when we run the app. We have some issue. Of course, in the view model, since we are changing the UI, that cannot happen on a background thread. So when our service is doing all of this stuff, it will automatically do all of this in the background. So before we update the UI, we have to make sure that it happens on the main thread. And with this async awaits, with the new Swift concurrency pattern, there is a new way of doing this. And that is a very simple way of just adding an @main actor annotation or whatever it's called in front of the function. And this will handle everything for us, so we don't have to do anything manually other than that. And now when we run the app, we should see a list of Pokemon names like that.